So, Mason Robot, why do you figure NP junction so be so important to the STEM problems? I mean, maybe I don't talk about it enough. I mean, we say some stuff about Bill Gates. We talk some shit about him and Zuckerberg and Elon and whoever else at the junction here today. Lego, which we'll be getting into in a moment. I'm more than confident into this, but the PN junction, the brick and dryer, obviously the same conjecture, the same theory on erodes. The map out, if you had to actually take notes on this, what would you expect them to look like? And ipso facto, go figure, n1 half, I usually keep them tight on this model, the hydrogen wave function being the photon we're going to put into this algorithm. Why does it come up so much in relative systems? Generally keep it parallel or passing through the wave function. What is this chalkboard? You know, just a little bit more advanced in terms of how the beta U, beta V, E to 1, E to 0, wave free particle, free conservation of potential, right? You know, we want to be able to conserve that math and not deal with too much index on the wave function. Well, it's a good problem. You kids know what it is, and you understand that that's not zero. It has to be some kind of well, that's what the world gives me, given Facebook, given my individual, well, again, the very specific media line here, and how I would present some of this material. Different once you get past the outer edges of the hot flaming universe. What is this chalkboard's inverse? Well, it's cosmic radiation background, Berkeley's final exam. What is 1 plus 5 in parentheses, x5, 5 questions for 5 minutes, you know, and the arc sign and sign of this classroom, and who can actually do the actual computations verbatim to what that wave functions. And this crypto, again at beta here, it wouldn't necessarily be hydrogen, it would be a base level of combinations that could range a gambit. Usually some probability of the way a wave function would break down, or at least decay states give me probability of timelines. If it's breaking down like cesium, right, you know, that's pretty stable, and you want to be able to or is it running like the damn rabbit out there on the farm, or is it a bunny farm? No, you know, on a bunny farm, usually the things running around acting a little weird, being hydrogen relative to durium, or out here at tritium. Arbitrary of the slope rise over run on the wave function here says a square or Carl Sagan universe loaf, depending on where I want to do that. I'll be right down! In that system, oh, fantastic, love that. Those kind of interference patterns come through in the wave to black holes that run around and they interact the same way, duality. In that system, you know, you kind of need to run the size of the monster being Dave inside of there. If I haven't said it before, the shadow problem with the packs. That is the pack running down to the trucker, the system, you know, what inverse, and knowing some gear works about limits under those systems, which have arbitrary lengths and systems, timelines, loops, or ways to say, well, if it runs 2 cycles here, it runs 2 cycles here, that's the IP address, and therefore I need to know what server to use inside of their infrastructure for Facebook. Why they were down for 5 hours that one day, Z. What was going on? We need to know. Stuff was happening. Things were weird. People are going to ask questions.
Solar cells to LEDs. So this is a very important lecture, and it's not just a guest lecture because
well, we do LED there, the photon, LED,
covered today. So over to
timeline in general,
Thank you, Zoe.
in any kind of matrix that would be in there, and then again anybody else's arbitrary model to these systems. Now, if you know the who, what, when, where with it all, given you know what this collision or these models may represent, let's get back to it here.
You may not be accustomed to that because this requires
Demo Ranch,
90%
Venus,
thinking
or
and 10% analysis.
kind
You
of.
may be trained to do it the other way around. So it's very important
Where
that
we're
you
living
look at the
here. I don't
concepts
get, you know, well, there's a
and
super
you
symmetry
dwell
to it,
upon
isn't there?
at length.
you know how that
Typically, to
plays
get
on
all the
certain
content is
ideals.
8 hours of work
What I
on
like
your
to
own.
again play is the 13
So
Ghosts.
please be prepared for that. If you understand
Cowboy
the
out here
junction
today
at this level,
sacrificing himself
your
about up,
electronics
down,
course
spin,
will be a
charm,
lot
top, bottom,
easier.
and all at
And you'll
once, and
have
the
a
Muon
good
running around the
fundamental
room, and
grasp
some quit.
to,
What, you're looking
to
at him
serve
stand
you
here,
if you
5 and
stay
2
in the
stick, putting it
electronics
together.
area.
Yeah, anyways, moving right along. Photon. Glue on. Look, you just did one.
Okay, a couple of
W
rules.
boson when
No
he gets into
talking
this
while
W
I'm
plus
speaking.
stuff about the
No
Z.
discussion
And figuring
until
it
I
out.
finish. If you wish to ask questions, just raise your hand. I will ask questions as well. Don't be afraid to give wrong answers.
Zoom.
Because most people share common misconceptions.
It's Carl
And so
Magnuson's
if it is wrong,
chessboard
I
right
will
here.
point out the correct reasoning. And
His new
everybody
website
benefits.
about how he
Okay, so I
decided
will
to
ask
do it
questions
against Beta U,
occasionally.
Beta V. I was like,
Test
well,
things.
I'll beat the
Now,
devil out of it with Zebra. Bob Rossi. Thank you very much.
Now what happened here? Alright, so we'll leave that one alone.
Check this out, right? Very
You've seen energy
interesting.
band diagrams, and it's sort of the modern approach to thinking of semiconductors, insulators, conductors, and so on. One can look at these PN junctions and all transistors purely in terms of energy levels and Boltzmann statistics and so on, but the inventor of the transistor, William Shockley, recognized that for most people these are very abstract notions, and that it would only be possible to use these devices if they could be understood in classical ways, using particles
IH.
and things that are very familiar
IH.
to us, rather than wave functions
IH.
and energy levels and so on. So I will give you a
Kinda get you into this
particle-based
kind of
approach to
supersymmetry
the PN
topology.
junction, because at your level of
Bullet and
learning, that is
keyhole,
the
why an
appropriate
order of this eventually is one of
approach.
those,
Then if
why
there
at
is
certain
need, you
stages
can
in
go to
phase
more
and
abstract
iron
ways,
core,
which are in some ways more correct
supernova,
later on.
mass gravity. They would,
Let me give you a
like
list
before,
of the concepts I will cover.
it would be,
We'll start
again,
with that.
after an event, really. I'm looking at the inverse, some Lenzin problem time-wise on an axis that changes it to size and mass and lens
Underlying
accordingly.
the entire
Because you put it in
PN
there,
junction
and you
and
put in
in
there
fact
some
all
numbers
semiconductor
too.
electronics
Because this makes it a
is
little bit more
something that is
Bernoulli
taken
M1 to
from
M2,
gas
but
laws and thermodynamics.
looks like you laid it real good
It's a
here about the
profound
hydrogen
relationship
wave function in
called
itself.
Boltzmann
And you're saying,
processes or
well,
Boltzmann
to
statistics.
a weight mathematically, given what would actually be
And I will
proportional or
illustrate this with a
packets to
simple
1
example in a
or
moment.
0, inside of there 1 to 2 by phase gives it a limit, maybe not its exact position. And that's, again, this topology right here. You're saying between this and this, they make each other. And if you're at S order of 5 sigma, right, you're going to be way
If I
down.
can hear you, you are violating the rules.
And at that
Stop
junction,
talking, please.
you know, that's like,
While
oh,
I'm
well, it's
speaking.
not its little house, it's not supposed to be in there, it can't really do it. And it's not the same thing in the same way, but there's wave function symmetry where there
Then
could
we'll
be a
talk about
lensing point in here on.
recombination generation,
It's not
which is
exactly,
unique
I'd want
to
to, just think a
semiconductors.
little bit more, this one up there a little bit more, and, you know, stretch this out by quarters, quadrants, inches, seconds, x's.
Because only in semiconductors
And then
you
yes,
have
because you like
two
it's a nice right here, and you're saying okay, maybe this
oppositely
length,
charged
and I get that that's
mobile
why that's fair inside of the square.
carriers or mobile
You know, it
particles.
lends, it bangs around
do
inside
not
of
have
there,
them
it's
in
kind of
metals,
doing all
and
that,
have
and
no
inside of
mobile,
there would be this
charges
thing
at all in
with this
insulators.
in it
Only
that
in
says
semiconductors
at the
do you have
macro to
things
any of those
which
levels
are
gives
equal
me
and oppositely charged. So there's this special
whatever
process that
mathematically.
kicks in. Then
Once
we'll
you get
talk
past
about
some of the
diffusion
proportional
and
amount of
drift
gravities
currents.
where that's relative to the molar mass calc that you'll need, and proportions amounts to the wave function, what is not just hydrogen, but the entirety of the periodic table passing through on one straight wave function.
I will invoke, it's not
You know, you're
really
going to want
a
to
concept
collapse that
where
a little
I
bit and
invoke
have
things
some
that you've seen
diagrams,
before,
NTFs that
but they'll be really
behave
put to
this
test
with
in terms of your
momentum
understanding
and
here,
probability
and they
that
are
do that.
charged
Again,
neutrality
given whatever arbitrary momentum you decide to send that thing out at, given
at
the range of
Kirchhoff's
spectrum
current
of where
law.
it is, when it is, how it is. So it's pretty nifty like that. Yeah. Sometimes I need to be the twister
All right.
theory in the middle of it. Every once in a while, I'm
Let's
dealing
start
with
with
where it's
Boltzmann
been in that
statistics.
area. Usually, like out here, Goldilocks zone, right? Delport.
All microscopic processes
You gotta know your enemy,
are
right? You gotta know
subject to
yourself.
thermal
Maybe study the
actuation
system,
and
get in
random
their house
motion
instead of just
because
arresting
of
them.
energy
Let's
received
do just
from the
count
sun,
first.
ultimately.
I won't judge or just do straight
so
up
if one
count.
has, for example, this is the surface of the Earth, and one has a big cylinder here which is closed, and inside this there's a gas, and this is the height from the Earth at a certain particular point here.
On the black body problem, this would be right
The
around
density of gas
high
particles here at
silica
this
composition, a lot
point,
of silica
N
out there, a whole
of
bunch of
H,
nitrogen hitting
is
real pegging
proportional
real
to the
hard from the atmosphere
exponential
point of view. When you get underneath
of
that, it might be
minus
different
U
about some of this other
over
stuff
KT.
going on, but
where K
given the
is
stock
Boltzmann
market today,
constant,
you never
T
know,
is
really,
absolute
man.
temperature, and U is the potential energy at that height for a particle
If
of
in the
mass m.
calculator and you programmed it to
What
be
this says
not
is
an
that the
apple,
higher
it will
you
not
get
do apple.
up there, which requires a larger U, you get an exponentially lower number of particles.
100%.
Now, it's all worth thinking about. You've studied this stuff. When you have gravity,
They're close.
everything
They're
is
close
attracted
to each
towards the
other, but
center
it's
of the
messed
Earth.
up. It's not
We
the right
are.
wave
That's
function.
why
Like
we're
you would say,
grounded.
oh, well, it's not just a peg
But
like that. It doesn't
why are
need to be.
gas
If I get them
particles
understanding this button
detached
toggle
from
switch,
the
and
Earth?
it's like
If they're
actually a
up there, they're
thermostat up here,
detached, they're
I'll
floating.
pissed off
We
somebody
don't
with the
float,
colors they're
they
looking
do.
at right now.
Why is that?
Interesting.
Why is that? You've all taken thermodynamics. Yeah.
Yeah, that's a great answer right there, Hugan.
Kinetic energy
Hugan
due
theory
to
about.
collisions.
Told me Yoda wasn't going to show
Which
up
is
today.
due to what? Due to what? What's that?
Yeah, get one together. It works like this. AR put it right to bear freedom and get the bear algorithm up here.
Due to what?
The reason it's my money now. Really,
Thermal
do you want to
energy.
understand the reason
Due
it's
to
my money now?
thermal energy. So thermal energy
Why
is
the STEM
received from the
problems are
sun
worth what they're
always.
worth, and they're
Everything
probably
starts
going to
from
keep you exclusionary
Okay,
to the
if the sun
system
was
unless
not
you
there,
can
we wouldn't
actually
be here.
handle what you're dealing with.
So it's received from the sun
Alright,
that
well,
actuates
okay,
these
then as long as
particles
you-
vibrate